All right, this is a video I was supposed to send out on Thursday morning, and now it's Thursday afternoon before I'm finally getting to it. I had a lot of trouble with my camera on my iPod and with recording, and then I had trouble with Apple setting it up. But I think now we're in good shape, and hopefully I won't have these glitches in the future. But anyway, you might not look at this on Thursday, and you might just look at it on Friday, but you're going to need to look at it, or you should look at it, when you start talking about identifying types of triangles. Now again, triangles are three-sided polygons, and we see them all the time, okay, but they look different. You have ones that look like this, okay, you have ones that look like this, you have ones that look like this, all right, and they all have different names, all right, and again, those names come in two different ways, by sides and by angles. Now, first of all, if I want to talk about triangles by angles, all right, there are three types, and they should look kind of familiar to you, the names at least should. The first is called an acute triangle. And again, an acute triangle is a triangle with all angles less than 90 degrees. All right, and again, you know an acute angle is an angle less than 90, so an acute triangle is a triangle with all three angles less than 90. And I think the kind of triangle most people think about when they say triangle, that's an acute triangle, because that angle is less than 90, this angle is less than 90, and this angle is less than 90. So an acute triangle is easy to notice because it has all three angles less than 90 degrees. Now the next one we would have, you could almost guess, would be an obtuse triangle. And you say to me, oh wait, I know, all three angles are greater than 90 degrees, duh. But no, it's not right, because you can't have three angles greater than 90 degrees. Because if you tried to draw a triangle with two angles greater than 90 degrees, or three, it wouldn't even make a polygon, because it would never connect. The truth is, if you have one angle greater than 90 degrees and you want to make it a triangle, the other two angles have to be less than 90 degrees. So an obtuse triangle is a triangle with one angle greater than 90 degrees and two angles less than 90 degrees. So in other words, it has one obtuse angle and two acute angles. Now, the last type by angles is called a right triangle. And a right triangle is a triangle with what? Does it have all three 90-degree angles, like an acute has all three acute angles? Or does it have only one 90-degree angle and two obtuse angles, like an obtuse triangle had? Let's see. Let's draw a right angle, and another right angle, and another right angle, and is that a triangle? No. By the way, if I continued it out, it wouldn't even be, it would be a quadrilateral maybe, but it would not be a triangle. So again, if I have one right angle and I connect and make it a triangle, the other two angles have to be less than 90. So it's like the obtuse one, except now it's a triangle with one angle 90 degrees and two angles less than 90 degrees. Now, so when you classify a triangle by angle, you're either talking about it being an acute triangle, an obtuse triangle, or a right triangle. Okay, and again, you look at the three angles. If all three are acute, it's an acute triangle. If only two of them are acute and one of them is obtuse, it's an obtuse triangle. If only two of them are acute and one of them are right, then it's a right triangle. But they all have at least two acute angles. If all three angles are acute, then it's acute. If the other one that isn't, if there's two angles acute and one that's not, but it's obtuse, then it's an obtuse triangle. And if two are acute and one is not and it's a right, then it's a right triangle. So that's by angles. Then you can talk about, excuse me, a triangle by its sides. All right, and when I want to talk about classifying angles by its sides, there are three situations you can have with the sides. Now remember, you have three sides. So the first kind is called an equilateral triangle. And an equilateral triangle is a triangle with all three sides congruent. And again, remember from what we learned before you left school that Friday, we learned that congruent means equal measurement. So an equilateral triangle has all three sides the same measurement. By the way, an equilateral triangle would look something like this. And because I can't draw that well, and because I don't have a ruler to measure them, if I want to show the sides are congruent, even if they aren't, I put a little line segment through each side, and that makes it congruent. So if you have three little lines through the sides, line segments through the sides, then it's an equilateral triangle, because that means all three sides are congruent. Now, the second kind you can have is an isosceles triangle. And an isosceles triangle, okay, is a triangle with two sides congruent. All right, and again, since those little line segments through the sides make them congruent, it would be one that had two lines. You could have one like this. You could actually have one like this. Or you could have one like this. And again, if you see the little line segments through the side, if you see two of them, that makes it isosceles. By the way, this is not just isosceles, it's also a right triangle. And this is isosceles, but it's an acute triangle. And this one is isosceles, but it's an obtuse triangle. So you can name it two ways, all right? And you can have an isosceles acute triangle, an isosceles right triangle, or an isosceles obtuse triangle, all right? And the last kind is called a scalene triangle. And again, scalene, okay, is a triangle with, what do you think? By the way, some people say with only one side congruent, but if you stop and think about that, that's a stupid statement. Congruent means equal measurement. How can you have only one side with equal measurement? Every side has a measurement, and you have to have at least two for it to be equal. So scalene is a triangle with no sides congruent. So if you see a triangle and there's no line segments through any of the sides, that's what makes it scalene. See, no sides with a line segment through it, no sides congruent, that's a scalene triangle. And again, if you had something like this, no line segments through any of the sides, that's a scaling triangle. And if you had something like this, none of the sides have line segments through them, so that's a scaling triangle. By the way, that's a right scaling triangle, that's an acute scaling triangle, and that's an obtuse scaling triangle. So again, you can classify a triangle two different ways: by sides, equilateral, isosceles scaling, and by angles, acute, obtuse, and right. And again, you need to know that stuff to work on that assignment. I believe it was on Google Classroom assignment number 2. I'm not sure. You'll have to look at the Google Classroom to find the assignment that you have to do with that. By the way, I want you to notice I drew 3 different types of isosceles triangles and 3 different types of scaling triangles, depending on whether the triangle was an acute triangle, an obtuse triangle, or a scaling triangle, or a right triangle. However, when I drew an equilateral triangle, I only drew one, and that was which type? Acute, obtuse, or right? And it turns out that it's the acute one because all of its angles are acute. As a matter of fact, you cannot draw a right equilateral triangle because if you have a right angle and you connect it to make it a triangle, one side is always longer than the other two, and that would be the side opposite the 90-degree angle. And again, it can't be equilateral if one side is longer than the other two. The same thing's true about an obtuse triangle. You cannot have an obtuse equilateral triangle because one side is always longer than the other two, and that's the side opposite the obtuse angle. So you can have 3 types of isosceles triangle and 3 types of scaling triangles, but you can only have one type of equilateral triangle, and that would be an acute equilateral triangle. And that leads us to the other thing you need to know for another, topic that you will be assigned, all right? And that has to do with finding the missing angle of a triangle. And again, when you have a triangle, if you know 2 angles, you can always find the third one. And the reason is because this is an important fact to know. The sum of the angles of a triangle is always 180 degrees. And again, it doesn't matter what triangle you have. If you sat there and you added up the 3 angles, it must add up to 180 degrees. And you say, why? And I say, because that's just what happens when you make one. By the way, at one time, years ago, I gave a class an assignment to prove that. To make a triangle out of cardboard and then to cut off the 3 angles and piece them together. And if you were to cut off the 3 angles, like if you would take this angle and put it right there, and then if you would take this angle and turn it upside down and put it right there, and then if you would take this angle and, just move it over here, notice what happens with the 3 angles. They put together to make half a circle. And how much is half a circle? It turns out to be 180 degrees. And by the way, you could do the same thing with an obtuse triangle or with a right triangle. If you don't believe me, get a piece of cardboard, draw an obtuse triangle or right triangle, cut off the 3 angles and piece them together, and I promise you, they always add up to be a straight line. And a straight line is half a circle, which is 180 degrees. So now that we know the sum of the angles of a triangle is 180 degrees, how could I find one if I knew the other 2? All right, well, that's kind of easy to try to figure out. If I knew this one was 56 degrees and this one was 63 degrees, and I wanted to find this one, think about that for a minute. If you know 2, but you don't know the third, but you know how much it is altogether, how much would the third be? Well, think. Let's see. Let's say Austin, Jace, and Braniff together have $10. And I know Austin has $6. He's always got money. And Jace has $3. He doesn't have as much as his brother. All right? But I don't know how much Braniff has. But if you stop and think for a minute, if Austin has $6 and Jace has $3, how much does Braniff have? $1. Now, how do you figure that out? Well, don't you find out how much the two you know have first, and then subtract that from the total to get how much the other one has? And that's exactly what I have to do here. I know what these two are, but I don't know what that one is. So I can add 56 and 63 together, and I get 119 degrees. So this one has to be the rest of it that adds up to 180. So take 180 minus 119, and again, that'll give you, this one is 61. By the way, you could check your answer if you wanted to by adding these three together, because what does it have to add up to equal? It has to add up to equal 180 degrees. Let's see if we're right. 61, 56, and 63. 1 plus 6 is 7, plus 3 is 10, carry you 1. 1 plus 6 is 7, plus 5 is 12, plus 6 is 18. And again, sure enough, it's 180 degrees. And again, it has to be, because the three angles of a triangle always have to add up to 180 degrees. So once more, how do I find the missing angle of a triangle? I take the two angles I know, add them together and find the sum, and then take that answer away from 180, and that tells you the one that you're looking for. So finally, we're doing some math. Supplementary angles we had to subtract from 180, complementary angles we had to subtract from 90, and now with missing angles of a triangle, we got to add and subtract. We're not talking about higher level math here, people, so everybody should be able to do it. And by the way, this is another topic that you'll have to work on. I apologize that it's going to take me so long to get this to you. It was supposed to be your assignment for today, but I'll most probably extend it through tomorrow. Just a side note, some of you have already done this section on classifying triangles. All right, great job. You must have used the examples they showed you to figure out what they were talking about. So again, if you already did it, fantastic. If you didn't yet, look at this video, and I'm also going to attach some notes for you to look at too. And again, between the notes and the video, you should have no trouble doing this. Good luck.